of multi-body systems. Let's tackle another one that we've seen physically before. I got this pulley system, and it says that it starts off so that mass 1 is 3 meters above the ground and mass 2 is 1 meter above the ground. If I was in a dynamics unit, I would talk about what direction the system tends to go in. Which direction does this system tend to go in? Yep. To the right, yeah. I mean, like, if I was in dynamics, I would talk about the system tending towards the right, and I would talk about acceleration of the system, tension, force, all that sort of thing. But as an energy argument, I just want to talk about what's going to happen to the system when not if, mass 2 hits the ground, because I can see that that's what's going to happen, right? Mass 2 is going to hit the ground. And so we're going to start off with that 3.00 meters and 1.00 meters as stated over here in my list of givens. So I've kind of organized it a little bit for you. But when it hits the ground, I don't think we need to come up with any fancy formulas for this. Can you guys tell me, what's the final height of mass 1 going to be? 4 meters, that makes sense. And we could just say, by inspection. That's a nice words way of saying I figured it out because it makes sense, okay? You could also say QED. You can look up the Latin on that one, but my friend Alex always said it was quite easily done. Anyway, this is 0 meters. We're going to start this one not from rest. It says that it starts at 2 meters per second. So V1 initial is going to be 2.00 meters per second. And V2 initial is going to also be 2.00 meters per second. Because we're going to treat this again like as it's a rigid system. So everything's moving together. We've made that assumption before. So if this one's going 2 meters per second down, this one's going 2 meters per second up. So it starts off in motion. It must have been released at some previous time. If you really wanted to do this thing math-wise, you could say H1 final is equal to H1 initial plus H2 initial. And you could say that's 3.00 meters plus 1.00 meters. So if you don't like QEDs and by inspection type statements, you can just say, okay, there you go, I showed my thinking. And we can also say we're going to let V1 final equal V2 final and just call it V final because it's a rigid system all stuck together, okay? And that's going to simplify our algebra as well. So I want to start off a similar way to the way we've talked about this maybe in the past. We could say E total initial is equal to E total final. Expanding out my total mechanical energy. Remember, we're only talking about translational kinetic energy and gravitational potential energy. So E total initial, I'll just do it all at once, would be EG1 initial plus EK1 initial. That would be the total mechanical energy for object 1 initial. EG2 initial plus EK2 initial. And then on the right-hand side, kind of mirroring that, EG1 final, EK1 final, EG2 final, EK2 final. And I'm so driven to simplify. Is there anything that can zero out here? Yeah. EK2 final. Look at that. It's going to hit the ground. Is there anything else that zeroes out for us? Does it start from rest? Nope. Does anything finish at the same height that it starts at? Oh, thank you. Okay. So you meant that guy goes to 0. Yep, that sounds good. We would have all been upset later if we didn't catch that. Thank you for catching that, Audrey. EK2 final. I should have left that in the video just for rage bait. All right. Anyway. Can you imagine? A bunch of angry engineering students or something? All right. All right, so we got to expand this whole thing out, and it's not going to be pretty, but it will be satisfying at the end, I promise, okay? But it won't be pretty. All right, so I'm going to start all the way at the left-hand side. Oh my gosh. And I'm not going to narrate this because, like, I think even though I could, I can't. So, maybe I should say it. Mass 1 AG H1 initial plus 1/2 M1 V1 initial squared plus mass 2 AG H2 initial plus 1/2 mass 2 V2 initial squared. And I was so committed to squeezing that in there, I probably could have given myself a little bit more breathing room. Let's see if I can do any better on the right-hand side. Mass 1 AG H1 final plus 1/2 M1 V1 final squared plus 1/2 M2 V2 final squared. And remember, nothing zeroes out here. And what are we trying to find again? Maybe I'll just highlight it so that it's really clear what we're looking for. We're trying to find, in this case, the final speed of this thing when it hits the ground. So I'm highlighting those two values, V1 final and V2 final, only because we're reminding ourselves that these guys are really V final. We'll put a stroke through them because they're really the same value, so we could just reduce that ever so slightly. But I think I'm gonna have to do some writing again. And I can, you know what? Hey, why don't I do something like, so I have one last line of writing to do, because this is a lot of writing. Why don't I take this term and bring it over? So minus M1 AG H1 final equals, and then I got to think about this remaining material and how I'm going to factor that out. So 1/2 VF squared is going to factor out, and it's going to leave behind M1 plus mass 2. And at least then, I got one less line of writing here, because I'm going to have to take that 2 over to the other side and take the M1 plus M2 over the other side. Okay, so I'm going to give myself, again, just like a little bit more space. Maybe I'll, yeah, you know what? I'll take that 2 over to the other side. 2 times, and then inside the brackets, now I got to write all this stuff. M1 AG H1 initial. Really, this just seems like a big exercise in being organized after you've got the basic idea down. So I'm going to multiply that whole thing by 2 as I take that factor of 1/2 over to the other side. And then, you know what? Again, because I don't like writing, I'm going to divide both sides by that M1 plus M2 binomial. And that'll leave my VF squared there. Is it okay with everybody in the room if I just square root both sides? Thank goodness, right? Motion passes. But here's the sad part. You still got to sub in all the numbers. So we got this like beautiful generalized equation for the final velocity of a pulley system with no friction, mind you. So we could still add more complexity into it. We're not going to. And a massless pulley. But now we got to sub in their values. So VF is equal to, and oh my gosh, I'm going to drop all the decimal places off all of my values, and I'm going to write real small. I'll even zoom in a little bit because this seems like almost merciless. And you know the worst thing is, if you forget to square the speeds on these guys and you're like, what did I do wrong? It's so hard to debug and find all these problems. Make sure that you do write the details in as you solve your problems, especially in your homework, because there's like a pretty high non-zero chance that you'll screw it up. Oh, I'm off page. Zoom out a little bit. And you know it's trouble when you're using a ruler to underline your values for division. I'm even going to use a ruler for writing the square root sign. Oh my gosh. Don't forget you're square rooting that whole thing. Imagine if this was a 3-body system. All right, so I'm going to just put it out there that when I did the math earlier, I got 3.1577 meters per second. Did anybody beat me to it? Yeah, I did? Nice. Wes, good. All right, so we're going to get this down to 3 sig figs. Nice. So if you got that, we can all be proud together. Approximately 3.16 meters per second. Did you? Nice. Dayton in the Hall of Fame. All right. And, you know, like, if you do get that, I think we can all just feel a little bit more like Sasquatch. Nice? Well, let's leave it there.